The following content has been provided by RWTH Aachen University.
To talk about design notations, let's take a very simple example. Let's say you find this code in BASIC here. Let's say somebody writes this code. And I'm not going to ask you whether that's a good program or a bad program. That's not the point. Or whether the user interface that this program creates is good or bad. That's not the point. My point is, by writing this program, you have specified also an interaction, right? So as a developer, you have specified an interface in a way because you wrote it down in BASIC and it will appear when you run the program. Why is that not such a good idea to specify your user interface in this way? What's the problem with specifying it in that way? Think about software architecture, about modularization, things like that. Yeah?
The user has no clue what the program will do with the entered number.
Okay.
It says enter any number.
Yeah. Well, so here's the thing, that's a misconception. Don't look at what the program does. I don't really care what the program does. I'm wondering about the language I use here to specify what the interface looks like as a developer. Does that make sense? When you write this code, these lines of BASIC, you are basically specifying a program's behavior, right? So you're saying this program will put out some text, it will wait for input from the user, and then it will output some more text and compute the results for the user and output that as well. Yeah?
It's really specific how the dialog would look like. So if you want to change it, you have to change every line and can't do it at one point.
Yeah, so that's getting to the core of it. The interface description, if you want to call it that here, is really intermixed with the algorithmic part of this code. Now, the algorithmic part of this code is ridiculously small. It's just basically computing the square of a number. But if this was a bigger program that computed some complex algorithms, some I don't know, tax calculations, and you would throw the interface in there with input lines and print lines and stuff like this with the algorithm, then it would really be hard to, like you say, I don't know, change the interface to French, for example. You'd have to go through and find all these print statements and change everything, a single line there accordingly. Plus, you would all of a sudden, you would be editing the source code of your program, which is supposed to run correctly and do something very specific, just in order to change some strings. And that doesn't seem like the right way to do it. The problem here is that we're mixing together the interface description with the algorithm, the business logic, if you like, or what the software is supposed to be doing. So that is that is the usual case in most normal programming languages, where the UI basically and the algorithms get mixed up. That makes it very hard to distinguish which parts will be determined by the system, because it's computed, and which things are being decided by the user because it's some kind of input. It also means that once you try to put all the error checking on your input, let's say you were actually going to write that program that I just showed you, you'd have to make sure that the user entered the correct number, and you'd have to make sure that I don't know, if it was pulling the square root of something, the number shouldn't be negative. All these kinds of things. So once you have all the error checking in your code, if you've ever done that, you're really foolproofing an input dialog. It's a lot of code, right? That needs to go in there that takes care of every special thing. So that will make your code very complicated and dominate the code. And at some point, once you've put all the error handling in, you can hardly find your original algorithm anymore. The first step, of course, is that you could say, OK, anytime I do some I/O, I will put that into a separate class or procedure or whatever. That's one way of handling it. But the question really is then, why am I using a programming language to specify a dialog? Right? Programming languages are there to tell the computer what to do calculations, computations, data processing, etc. Not so much in order to specify what an interface looks like. Can't I use a more efficient, more readable language that is just better to describe an interface design concisely, and then somehow process that language description into the user interface. And that's basically the idea behind most of the interface design languages, interface design systems that we'll be looking at now. You can do that a priori, so you can basically say, before I write my code, I'm going to design the dialog, and you design that in some kind of wonderful notation system, graphical, textual, whatever, and then it basically gets processed into the description. It could just be for the development team, if it's just human readable, or it could actually be automatically translatable into working interface code. We'll see examples of both. So now the problem that we're looking at is now we want to describe the proposed design of a user interface. And of course, hey, we're all computer scientists or related disciplines here, so we love inventing new languages, right? So whenever there's a problem, you invent a new formal language for it to solve it. And you can do that. You can come up with a language, a description language that describes the user interface. And all the standard computer science techniques apply that you can use there. And the only problem with that is that the more modern the user interface is, if it's graphical, multi-touch, whatever, gesture, voice, the harder it will become to describe that interface specification textually. If all my interface does is like what we just saw, inputting, pressing keys on a keyboard, no mouse, no graphical input, it's easy to write down a textual description of how my interface works. If it gets very graphical or uses different modalities like gesture, speech, essentially, etc., it becomes a little harder to write down.
This content was provided by RWTH Aachen University.